All right. Good afternoon. This is Mr. Gubino, or good morning, whether you're watching it now or later in Wednesday. So this is technically 8 o'clock in the morning. We're going to be talking about kites today. So the notes packet that you should have that starts off is going to be this packet right here. We're going to start with this, and there are maybe 4 other pages of problems that we will go over. We'll go over a couple of them, and I'll expect you to have them done by Friday. And then there will be a quizzes to do. Delta Math does not have any kite stuff to do, so that's good for you guys. So you'll just have the worksheet to finish up. You'll have the quizzes to do, and then you'll have a scavenger hunt, another scavenger hunt. I'm taking off the Flipgrid because that didn't really work for me, and only 4 people did it. So you guys like doing slides, so putting a slide up on Google Classroom was great to see, and I got to I love seeing everybody's objects that they found, like the puzzle one for the tessellation, and the one with Miss Nottingham's sister got the best look. I can't do the one eyebrow raised, and it gives me a little twitch over there, but she nailed it. So that's awesome. Tell her she gets 100 points. Today, later today, 10:40 again to 1 to 11 o'clock. First hour we'll be meeting. Second hour or fourth hour we'll be meeting at 11:10 to 11:30, and sixth hour we'll be meeting from 11:40 to 12 o'clock. Just a 20-minute session. You come in if you want. It'll be a Google Hangout. You'll leave in 20 minutes just to check in, see how everybody's doing, if anybody's struggling with anything, just to say hi, see me in person with my scruffiness, and we'll go from there. But again, not mandatory. Just seeing if you guys wanted to show up. We'll talk and see if anybody's watched a good film or anything like that. And if you're Parks and Rec fans, Thursday night at 8 o'clock, that's where I'll be on NBC. They're doing a Parks and Rec show from their houses. So I think it'll be Leslie Knope and Ron Swanson. All right. So here we go. We're going to go into kites right now. I'm looking over at my monitor, so every time that you look, I look like this. I'm looking at my monitor just to see if I'm looking right. If I look this way, I'm looking down at my document camera right here with my screen. So let's get started with kites. So I'm going to go on this first. So the definition of a kite, again, you can pause this at any time that you want. It's a quadrilateral that has 2 pair of consecutive sides congruent, but opposite sides are not congruent. So we're going to go back to those little triangles that we did, and we're going to construct a kite. So this is not necessarily a right triangle. It is going to be the triangle kind of that goes along with this. I try to get it as best I can so that you see this right there. So if I name that angle 1, this angle 2, and this angle 3, with side, let's do A across from 1, let's do B across from 2, and let's do C across from 3. So has sides 1, 2, and 3. I'm going to pause it there. You should pause it, and I'm going to trace that triangle. Okay, that took longer than I thought. You don't have to trace that. You don't have a triangle to trace. So I'm just talking about this triangle right here. So this triangle right over here is angle 1. This big angle would be 2. That would be 3. That's A, and that's C. B is AC. So B would be that diagonal that goes right there. Okay? So I just want to kind of look at it in an aspect here with this. So what I'm going to do, and if you know what I'm going to do, I'm going to obviously do something to that triangle, and the thing that I'm going to do is I'm going to reflect that over that side. And so what I get is a kite or a shape, a quadrilateral that looks like this. All right, so this segment that connects this common side, this is what we call the diagonal again. Remember, a diagonal does not have to go diagonal. It just has to be connecting two vertices. So if you notice the diagonal there, I create these two, and give me a second, let me trace that. All right, so when I trace that, magic of editing. So thank you for, I think that was Michael who told me about that. We can have this with the two triangles. Now, if you notice, we got a couple things that happen here. We got a pair of congruent angles, one pair of opposite angles that are congruent. Here are my two sides that are equal. Here are my other two sides. So these are my two pair of consecutive right after another, but opposite sides are not congruent. So A can't be congruent to C. Now, if I look up here, I have angle 1 and angle 1. Oh, well, those two angles are going to be the same. And what does B do to this big angle? This is where A is going to be. That's right. When you paused it and you answered the question, or you answered the question just now, it's bisected. That angle is bisected. So big angle A is bisected. Also, big angle, what letter is that? C? That's also bisected. Okay, so when we're looking at those values, these two sides right here are equal. The two A's with my bleeding highlighter, and then my two C's are going to be equal. So these two sides are going to be the same. Likewise, these two sides are going to be the same. All right, now there's another diagonal that I can draw. And when I draw that other diagonal, it's not necessarily going to bisect it, but it is going to do something to those. And I'm going to show you that here in just a second. Let's say that this is 100 degrees. And let's say this is, let's say that's 50. So this would be 30. So the triangle has an angle sum of 180. Therefore, this would be 50. Notice it gets bisected. This is 30. Notice it gets bisected. And this one is 100. So if you notice, the congruent angles, these two are congruent. This big angle right here would be 100. Just a coincidence that those two are 100. But if you look down here, this one's 60. So this pair of angles aren't congruent. Opposite angles aren't congruent. Because if you have those pair of opposite angles congruent, then we have a parallelogram. And this is just a quadrilateral. So there's no parallel sides. No parallel sides. All right. So what we are going to do next is we're going to draw this other diagonal, because you have two diagonals in there. I'm going to use, what color haven't I used? Where's my green? There you are. Way over there. So I'm going to connect these two. Now again, you're going off of what the notes are. So in this case, this is D, and this is B, and this point right here is E. So I'm basically drawing this shape. I got the 1s, I got the 3s. This big angle is 2. This big angle is 2. Now, what's going to happen is this. When I get this angle right in here, what is going to happen is this angle is going to be the same as that angle. Why? Because if you look at where this diagonal hits, if we think back to, that's right, congruence in triangles, this triangle right here is going to be congruent to the other triangle across from it. I'm going to take out some colored pencils here. So this triangle right here is going to be this triangle right there. So if I cut off the top of this and cut it across, that's going to happen. Now, what is that triangle? Well, by side, angle, side, these two triangles are congruent, which makes every other angle and every other side congruent, which makes this side equal to this side. So we're going to go over those properties. I'll give them out up here in just one moment. Now, the other thing that we haven't learned, sorry, my back went out, is that what happens at E? Well, E, if you've flown a kite, this looks like a kite, therefore we call it a kite. If you've flown just a general kite like this, not one of the ones that look like, you know, the bird or anything like that, if it's just a regular kite, then right in here, these are all going to be right angles. These are all 90-degree angles right there. So what happens to this? Well, 50, 90, and this would be 40. And if that's 40, that's 60, because 60 plus 30 plus 90 is 180. So notice what you have is you have two triangles, two pairs of congruent triangles. We have the pair of the blue ones, and we have the pair of the red ones. These two triangles are going to be congruent. So if you remember back to parallelograms, we get two triangles, we get four pairs of congruent triangles. If we draw a rectangle, we have two pairs of isosceles triangles. We have a rhombus, we have four right congruent triangles. If we have a square, we have four right isosceles triangles that are formed by the diagonals. Trapezoid doesn't have one. It has those, the isosceles does, has the two congruent ones on the sides with the leg, and then the two similar ones. Whereas in a kite, you're going to have a little bit different. So we're going to come back to and transition back to those, and I'm going to go over the properties. All right, so here we go with the notes. So you got the definition of a kite. Kite is a quadrilateral that has two pairs of consecutive angles that are congruent. All right, let's talk about this. So, properties of a kite. It is a quadrilateral. So in the quadrilateral, we know that it has two pairs of opposite sides. It has four sides. It has an interior angle sum of 360. And that is for the big angles, not for the small ones. Hold on for 1 second. Okay, sorry about that again. So I went ahead and stopped the video for a second, wrote out the properties. I will scan this in. If you have time, you can just pause it right here and write down the property. I'll go over the properties here in just a moment once you've gotten them written down. Excuse me, I'm hiccuped. So go ahead, copy those down, and I will get back here in just 1 second. Once you get them done, you can follow right back in. All right. So property number 1 states that the quadrilateral has an interior angle sum of 360 degrees. So the big angle A plus the measure of angle B plus the measure of angle C plus the measure of angle D is still 360 degrees. Got it. It has two pairs of congruent sides. We have AD being congruent to AB, AD being congruent to AB, and we have CD congruent to BC. So these two are going to be congruent, and these two are going to be congruent. So for instance, let's say this was 5. This would be 5. That's not a 5. That's a 5. And if this was, let's say, 7, this would be 7. But you don't want opposite sides congruent, because then it would make it a parallelogram. Okay? Next, one pair of congruent opposite angles, and that is the big angle D and the big angle B. So these two big angles right here are going to be congruent. We said that these were, let's say, 100 degrees. Okay? Diagonals are perpendicular. Oh, Okay, so diagonals are perpendicular, which makes all of these angles right here 90 degrees. What other ones have perpendicular diagonals? Perpendicular diagonals, and if you remember, yep, that's right, a rhombus and a square have perpendicular diagonals. So does a kite. All right. 5. One diagonal bisects the non-congruent angles. So this diagonal, these are my congruent angles. So my non-congruent angles are A and C. So this diagonal is going to bisect them. Okay, so the angle that is not hitting the congruent angles, this one gets bisected. So angle 1 is congruent to angle 1. Angle 3 is congruent to angle 3. I think we said if this one was 50, this would be 50. Yes, in coincidence, that's 100, which would make this 30 and this 30, because in that right triangle over here, that triangle had an interior angle sum of 180 anyway. Sorry, my headphones fell off. Everything's going right for me today. All right, so this big angle was 60. Just to check, 100 plus 100 plus 100 plus 60, 360. Perfect. Okay. One diagonal bisects the non-congruent angles. We just talked about that. And then the last one is that one diagonal is bisected. And the diagonal that is bisected is the other diagonal that doesn't bisect the angles. So this one gets bisected. Okay, now it can't bisect both, because if it bisected both, you'd have a rhombus and a square, because they are perpendicular. Now, at some point, those diagonals could be congruent, but we're usually not going to say that. So we're going to talk about this and what the shapes are with each of those. But those are the 6 main properties. I'll probably just leave it. Now, a kite, the one that we had, looked like this. Okay, I'm going to show you a different kite, and a different kite is a kite that is, this is what we call a convex kite. It opens out. None of the diagonals are inside. If I do this and I construct it like this, all right, then what happens is that is a concave kite, because if I draw this diagonal that goes across from there to there, it's going to be outside of the diagonal. I'm still going to have a pair of opposite angles that are congruent. I'm still going to have that diagonal that connects this vertex to this vertex, bisect those two angles. Yes, this big angle and that big angle will be obtuse. Then you'll have this angle bisected. But this is a concave. Notice this side is congruent to this side. That one's congruent to this one. Don't look at that little yellow part, should be orange as well. Okay, so that's a concave kite. We've been dealing with convex kites. All right, we are at the 18-minute mark. I'm going to get moving here. So let's go to the first page of notes, our packet of notes. All right, so here's our congruent sides, there and there. The congruent angles, give you a little hint. Congruent angles formed by the non-congruent sides. Which means that this side and this side form the 125, which makes this side and this side form the 125. Okay, then you can use your handy dandy calculator, and you know that 360 is the sum. So you're going to subtract 125, 125, and 82, and you're going to get an angle of 28 degrees. Okay. Which two would be bisected? That's another question I would probably ask. These two would get bisected. So this bisected, if that diagonal hits those, each of those would be 41, and each of these would be 14. And if you notice, if I bisected those, what would have to happen is this 41 and this 125 and this 14 should add up to be, oh, look at there, 180. Perfect. So if we had this diagonal, we'd have a triangle, that yellow triangle and that orange triangle, we'd have each of those bisected. All right, I'm going to go down to this one. You can do that second one. I'm going to go down to this one. I have the diagonals drawn. I have the congruent sides. Now this isn't drawn, but it is basically the same picture. So I should probably give you at least that those two sides are going to be equal. This angle right here is a 20-degree angle. This angle, these four, are going to be 90 degrees. And if that's 90 degrees, and that's 20 degrees, 90 plus 20 is 110, which makes this 70. Oh, so we have that little tiny triangle right there being 70 degrees. If that little tiny triangle right there is 70 degrees, this little tiny triangle is the flip of it across that side. So if it's across that side, that's 20, that's 70. Yep, that is right. Okay, now, how are we going to find the other ones? Well, I got a 35 down here, which makes this 35, which makes this big angle 70. Oh, that big angle is 140. Now, if I just knew those two and I wanted to find that, I could use the triangle sum and take 180 and subtract 35 and 90. Okay, but in some cases, if I don't have that, I know that this triangle forms, and if I take 70 and add 35 and add x, I get 180. So you know that x is, let's see, that's 105, that would be 75. So this angle right there would be 75 degrees. Rewind that if you didn't see it. So in that triangle, all right, let me see if I got a little smaller version here, a yellow one. It's not the same, but oh, it's very close. So if this was 70 and this was 35, I could find what this big angle was, which was 105. Now, if I split this, if I cut it and put a 20 in there, oh, now I got the angle addition postulate, which makes this angle, oh, 75, sorry, 75. 20 makes that 55. So these two angles should add up to be that. And if I take the 35 and the 55 and the 90, I get another 180. 55, 35. This angle is 75. This one is equal to that one. It's across from it because it's made up of the two sides that are not congruent. This side, these two congruent sides make up an angle that is bisected. These two congruent sides make an angle that is going to be bisected. Let me state that one more time because that is very important to the process of this in finding angles. The two sides that are congruent form an angle that will get bisected. Since these are congruent, this is going to get bisected. Since this is since these are congruent, this is going to get bisected. These are not congruent, and if those are not congruent, these two are going to be equal. So if they're formed here and these two are not equal, these two are going to form the equal angles. Okay? Rewind that as many times as you can. It's 23 minutes. You might hear my son over there screaming and yelling. I'll go yell at him here in just a second. So the last one is Pythagorean theorem, which you know and love. So we're going to find the sides, the missing sides. And these are sides, these are not angles. You know that the Pythagorean theorem is a squared plus b squared equals c squared. You know we have a side, and these are all right angles. You know that if that's x, this is x. If that's y, that's y. This one is not bisected, which means this one is, which makes that 5. So if you notice, I have a triangle. So 4 squared plus 5 squared is x squared. And then I have the other triangle, 8 and 5 and y. So I have 5 squared plus 8 squared is equal to y squared. Oh, you remember this, don't you? 25, 16, 41, x squared, and then x, we take the square root. Before Corona, we did that, BC. So here we have 25 plus 64 is equal to y squared. Y squared is equal to, what is that, 89? So y is equal to the square root of 89. Remember, those are good enough answers. If you feel that you need to put them into a decimal form, square root of 41 is a little bit more than 6, and the square root of 89 is just under 9. So what I want you to do is replay this as many times as you need to and go through things. If you do have questions, shoot me an email. If you want to ask questions at the 20-minute session tomorrow, reminder, first hour, 10:40 to 11 o'clock. Fourth hour is from 11:10 to 11:30. And then sixth hour is from 11:40 to 12. So 20 minutes, first, fourth, and sixth. And we're going to do that every Wednesday. We can talk geometry if you have a specific question, but I don't want it to be geometry. I want to see how you guys are doing, and go from there. See if there's any shows that you've been watching. Again, Parks and Rec is on Thursday if you didn't hear that lately. So I hope all is well. This is a nice 27-minute video. I'm sorry for the length, but it's got a lot of information about kites. Okay, so enjoy, have fun, ask questions on email if you need help, or schedule a Calendly. I'm going to be changing that up just a little bit, but you'll not be worried about it. That last part was bad. Okay, it's getting late. I got to go to bed. Have a good night and or day, whatever you got, and we might see you later. Or we might have saw you already. I don't know. Okay. Take care. Bye.